Hello, dear viewers of this podcast. I would like to welcome you to a conversation with Urs Hölzle about generative AI and AI in general. My name is Sandra Setier. I would like to introduce Urs Hölzle to you, a true innovator in cloud computing. As one of Google's earliest employees, he was at the forefront of developing Google's infrastructure that powers much of the internet today. His work on energy-efficient data centers, distributed computing, and software-defined networking has been groundbreaking. He is a respected figure in the tech industry globally and a role model for aspiring engineers. Urs, welcome to the podcast.
Thank you.
And welcome to Switzerland. I learned you just came from the Silicon Valley.
That's right. Yes. Always nice to be back.
Much appreciated. And as I just said in the introduction, you were one of Google's first employees, number 8 to be precise. You joined Google in April 1999. It had only been founded half a year earlier. However, your life started in Switzerland, in Basel. You were born and raised in Basel. Then you moved to Zurich to study engineering at ETH. And then you went to Stanford for your postgrad studies, where you met the two students, Sergey Brin and Larry Page, young founders of Google, who managed to convince you to join a startup that had just been created in a garage. Mm-hmm. Tell us, how did they convince you?
That was a little bit of a coincidence. You know, we met through mutual acquaintances, and I wasn't actually thinking of doing something in search because I had no background in search. And so, in fact, the first time someone told me about Google and said, oh, you should talk to them, you know, this is interesting, I kind of dismissed it because really I had no idea about search. I'm a systems person, and search is, back then, was called information retrieval, completely different field. I'm like, I don't know, you know, what I would do there. But my wife at the time was at Stanford. I was at UC Santa Barbara, which is about 500 kilometers away. And it kind of got tiring to commute over the weekends. And so I was looking for a 1-year job to wait for her to graduate. And then we could together figure out, you know, where to go next. I was kind of looking for a job.
So what were the arguments that convinced you to join this very young startup?
You know, you have to kind of put yourself back at the 1999. It was sort of the height of the internet bubble. And I had gotten lots of inbound interest. You know, why don't you work for this? Why don't you work for that? You know, everyone was hiring. But generally speaking, most companies didn't really have technology. They didn't really have a mission. It was really sort of do something on the internet and, you know, sell this or sell that. And what was really different about Larry and Sergey and actually the early employees was that they were highly technical and they were all talking about the mission, not about, you know, going public and you know, how big a business this would be and you know, et cetera, right? And so it's very clear that they were really after solving this big problem of how do you find stuff on the internet, which at the time was really terrible. Search was really terrible. So that was number one. And number two was that it was sort of clear that it would be interesting. Remember, I was looking for a job for 1 year, right? Take a year off from university and then, you know, go somewhere else. And so I was looking at this and saying, well, even if it doesn't work out, it's going to be technically interesting. I was an academic and there's going to be interesting problems to solve. So it's not going to be wasted time if I spend time with Google.
So the two founders asked you to build Google's first data center. And I heard Larry Page say in an interview, they couldn't have built Google, they couldn't have scaled Google up without your help. So you came in to build the data centers, so to speak.
I wouldn't say data centers because we weren't really doing data centers. We were renting things. But I'd say more generally infrastructure. My first job title, we could pick our own job titles. And so my first job title was search engine mechanic. And I picked it because everything was broken, right? Like Google barely worked. every day it would go down basically at the middle of the day because there were just too many queries and it would crash. And more generally, it had just gotten out of Stanford. So it sort of was, working in the sense that it produced good results, but the way everything was constructed, the way the code was written was really sort of a university product, and it wasn't intended to serve millions of users. Right? And so what they were definitely looking for and what everyone was struggling with actually for the first 2 years easily was how do you handle the volume? How do you have basic reliability? How do you refresh an index at least once a month? Right? Back then, that was our goal, right? Once a month, we should crawl the web again and get new web pages so that your search could find something that's,
Yeah.
not yet a month old. And so all these basic things, that was really almost sort of survival mode, like really the very, very basic things that were all broken at the time.
That's interesting. So you went from being employee number 8 to now Google almost employing 200,000 people, being one of the most valuable, one of the most recognizable companies around the world. How does that make one feel? I think that's something no one else here can relate to. How does that make you feel?
I would say surprised still. I mean, because, back, the world was very different 25 years ago. The internet was new. Many people used it still through modems because there was no home internet really other than a phone line. Our query volume was higher during the week than on weekends because during the week people in the office had better internet connectivity and actually a search. So it was really a very early time. It was barely things sold on the internet. And so there's, no phones, no graphics really, no video.
Yeah.
And so to me, what's really surprising is how powerful sort of incremental growth is if it goes on for, 2 decades. Because even, you can understand, let's say 50% change in 1 year. But if it happens again and again, it really puts you in a very different place. And that is really hard to anticipate. And so I wouldn't have thought back then that even though intellectually, I understand exponential growth, I really didn't think of it in the way of what it has become.
Yes, it's all about sticking to a good thing. And I absolutely remember the sound of those modems when you went online. You weren't online, you went online back then.
Exactly.
Yes. So Urs, when I was preparing for this podcast, I sat down and thought about all the fields that we should touch upon when it comes to AI and generative AI specifically. And I was sitting there for about 2 or 3 hours, and only then it occurred to me that I could have asked Gemini, which I did. And Gemini, within less than a minute, came up with a brilliant set of questions I could ask you, touching pretty much all the fields that I have come up with. So this was another stark reminder of the efficiency that can be gained or the time that can be lost if we don't use Gemini, our large language model. So I would like to ask you Gemini's questions.
That's great because I use Gemini to get my answers.
Great. So I did ask Gemini in a podcast with Urs Hölzle about artificial intelligence, what questions should I ask him? It came up with high-level questions, questions specific to the area of AI, and some personal questions as well. So I would say let's dive into the high-level questions. And the first one is, what are the most exciting developments you're seeing in AI right now, both at Google, but also in the wider research community?
That's a difficult question, actually, because there's so many things going on. And so in a grander scheme of things, to most of us, it looks like AI just sort of came to the forefront, a year, 2 years ago. But in reality, it's been going on for at least 10 years, where suddenly 10 years ago, sort of some things started to work that before just had not worked. And that was really, for example, machine translation, became much, much better. But what was really remarkable was that every year the progress was, astounding, and that's still true today. So it's hard to name just a few things, but to name some, one of the things that's super exciting is that obviously the quality is getting better rapidly, but also that the cost per query, so to speak, is going down, very, very rapidly. So it actually has been not uncommon that year over year, you get a factor of 5 or 10 reduction in compute cost for the same quality of result, because the hardware is getting better, the software is getting better, the algorithms are getting better, and actually the machine learning is getting better. And so to me, that's actually perhaps the most exciting one, because that means that models that today are very expensive, right, that are really sort of state of the art, the leading things, they produce very good results, but they actually really are super expensive to just answer a single question, that they actually in a year or two are cheap enough that they might even run on your phone and give you answers very quickly. And so that we can realize sort of the promise that is sort of there in the research lab very quickly in the actual real world in a way that's cheap enough for everyone to be able to use.
Yes. Energy consumption is also a topic there, both cost-wise but also environmentally. How do you see the progress in that area?
That's really actually very much related. Compute is basically energy. And so if you can reduce the amount of compute by a factor of 10, you probably reduce the energy by also around the factor of 10. And so I actually think that's not going to be a huge problem. There are, lots of forecasts that forecast enormous amounts of energy being used by AI. I don't think that will happen. And the reason really is that while demand is increasing exponentially, technology really does not stand still. I'll give you another example. We looked at, actually published a paper 2 years ago at sort of the 5 years from the invention at Google of the modern sort of LLM technology called Transformer. So from 2017 to 22, the computation to get to the same quality answer, the amount of computation went down by a factor 88, right? So almost a factor of 100 reduction in just 5 years. Right? And so that means even though the growth of demand of queries is clearly, going exponential, it's kind of attenuated by also an exponential improvement in how well we can do that computation and therefore how expensive it is. And so I think the actual increase is going to be, the actual power consumption is not going to be, that huge. And then the net benefit, I think, is much larger than that. For example, using AI for energy efficiency in buildings, or to give you another example, using AI to make weather forecasts. Google DeepMind system just published a few months ago can give results that are as good as the European weather model, and it can do it on a single machine in, I think, a minute or two, versus using a supercomputer that runs, with thousands of processors for several hours to give you the same results. So that's just a glimpse of what's possible and where a huge amount of energy is being saved by doing an AI computation versus a conventional
Interesting. And I heard you were also using artificial intelligence in data centers to
That's
make
right.
data centers more efficient.
Yes.
So using AI to make itself more efficient.
In a way, yes. So we did that a few years ago, and basically that is quite simple. You have a big building and it has all these fans and pumps and cooling towers, and so there's actually lots of knobs to turn. And for a given day, you have a given load on your data center floor and a given humidity and the temperature, etc. And there is probably an optimal setting, but what would it be? And for a human, there's just too many knobs and too many things changing to ever kind of find the right knob. But it turns out that if you train a machine learning system on this problem, it can create a customized sort of control program just for this building, that on this day, just for this particular day and this particular way how you're using it today, can sort of dial the knobs, and in that case, saved us in the summer about 40% of cooling energy. And so that's just one example of what AI can do to reduce energy. And so overall, I think the energy reduced by AI will be substantially bigger than the energy used by AI.
And with all of those advancements that you've just mentioned, how do you think AI will reshape the world in the next 5 to 10 years? And that's also Gemini's second question to you.
That's really hard to tell. I mean, I think there's clearly places where it's already visible how AI can really change things. You mentioned Gen AI, generative AI. I mean, it's really good at generating sort of new ideas. Could be, text, images, videos. And so I think in the creative industries, it's clearly possible now to try 100 things, whereas before you only had time to try 1 or 2. And so it's a very different way of working. Similarly, I think in a way, AI is now like a calculator for language. You had a calculator for math. And so you can now multiply to 7-digit numbers and you don't think anything of it because you have a calculator. Now, if you don't know English as a native language, you have something that actually can sort of do the English calculation for you, can correct your text and help you write, professionally in English, even though it's your second language. Right. So there's a few areas where it's very clear. Our hope, of course, is that it can really change the way search works, from giving you, just 10 blue links to actually being able to summarize, to actually give you answers. That is still a research problem to some extent. So these AIs are not actually intelligent yet, right? They're really great at certain things, but they're not great at facts, and they're also not great at reasoning, like combining these facts. And so, but they always sound great, right? And that's sort of a tricky combination if you want to do search, where people actually come to you for correct answers, right? For authoritative answers. And so the standard there is very high. And right now, today's models just aren't quite yet at that standard. So you have to do a lot of things around it to make sure that the answers they give are actually truthful. Right? So I think in the next 5 years, hopefully that's solvable, at least for many queries, maybe not for all queries, but at least for many.
There are also a few podcasts like this one who speak critically about AI and its future in the next 5 to 10 years and what it means for humanity. That AI, as you mentioned today, is not really intelligent yet, but it could become. How would you respond to those concerns?
Oh, I think it's a real issue, and I think like technology in all its forms, from the steam engine, right, to cars, to phones, to AI, changes really how we interact with the world, how we interact with each other, what's easy, what's hard. And I think especially the ability to process language and actually generate language is sort of radically new, right? And meaning that until now, to form, an intelligent sentence and an intelligent paragraph, you need to be human, right? And I sort of recognize another human by their speech, right? I understand another human by their speech. So what does it mean if there's a machine that's speaking, right? And then what if that's being abused, for example, to comment on public forums, right? Here's an internet forum, and I use AI to just go answer everywhere and make my point, right? That can kind of quickly make those forums not really useful because the human voices get outnumbered by machine voices. So there's lots and lots of problems that really change. Just like, let's say, when the mobile phone came around, information now really instantly reach people that before may have reached you after hours, and that kind of reset expectations of what's normal, what's being expected, etc.
And that is a good example of something that requires rules as well. I think we've all come to learn that our smartphones require some rules, particularly when it comes to our kids and to our youth. There might be some challenges to, in that case, that hardware, and in our case, to that technology, which brings us to the point of regulation. What is your point of view about how AI should be regulated? And I know it's a tough question because we don't know yet what it is going to evolve into.
That, I think, is sort of the biggest challenge. If you want to make rules about something, you kind of need to understand that something. And so it might be a little bit too early to really be strong on rules because we don't quite know yet what is relevant even in a few years.
Sorry, would you say until it's not intelligent, it doesn't need much regulation?
No, not at all, right? I'm just saying that as a tool, and it doesn't matter whether it's intelligent or not, right? It's a tool. It's the newest form of AI that that actually really does language well, has been available for a year, 18 months, right? So it's kind of very clear that actually the tool itself isn't fully formed, hasn't played out, right? We don't know yet how it will be used really. And so as, if you ask me like, what are the consequences, how will it play out, right? Like, I don't know, right? This is a very complicated question. And society kind of deals with things, in all kinds of ways, right? And it's just hard to make good rules other than very high level rules. Like, let's say we have our AI principles at Google, right? We published them 2018, so a long time ago. But they're fairly high level, right? They're really more principles that you should think about when you develop AI applications, and they're not rules or regulations, right? So those things work, right? If you have high level sort of guidelines, do you think about harm? Do you think about bias? Sort of things like that. But that's very different from a regulation, which would say this specific thing is in and this specific thing is out, or you can never do X and you can never do Y.
Yes. I have the AI principles here. Let's speak about them briefly. So our first principle is be socially beneficial. In your words, what would you say that means?
In the end, Google does creates technology, and our aim always has been to do something useful, right? Something beneficial, right? Like search is there, but even ads, right? Connect people with a buying interest to people with a selling interest, but we're trying to do it in a way that's really relevant to both of them. And so this is an extrapolation of that into AI. If you're using AI, then there really should be a purpose that, generally speaking, is recognized as beneficial. It can't always be 100% beneficial, but it should really be, primarily beneficial.
And focused, right? So we wouldn't engage or develop whatever is possible, but only if it's focused on that benefit. The second one is avoid creating or reinforcing unfair bias. And that's probably the principle that we have been, if at all, touched by the most in recent months. In your words, how would you say, do we manage to avoid that bias, but also not overdo it and eventually show things that are generated, but that are not historically correct?
Yeah, so I think bias is actually a very complicated topic just by itself, because some of it can be sort of very overt, whatever, women are worth less than men or something like that, right? But others are actually kind of very indirect, where you don't really directly bias something, but it is emerging. So, for example, maybe there is when, suppose you automate loan applications and you have all kinds of information, you may upending discriminating against a certain class of people, like being less likely to approve them, even though you didn't know their race, for example, right?
Yes.
You may actually still turn out to be biased against a certain race because of correlations in the data that are out there, right? So bias is a complicated thing. And the most important thing is to actually measure, to try and evaluate what you do. So the big step that always is there is to say, let's test the answers, the function, the system that you built, and can we hypothesize what biases it might have, and then can we test it with example questions to see, does it exhibit that bias, right? And obviously you're trying to then also perhaps build in things to make it less biased, and sometimes that itself can create a problem, right? In the example that you mentioned, it was actually really a too overly simplistic implementation of something saying, hey, if someone asks for pictures of people, don't show them just the most popular pictures, but show them a range of pictures, right? And then that led to the fact that, but the bug in that was that this was always applied versus only when it's really about non-historical figures,
Exactly.
right? And that really shows how complicated that is. You know, the world's information is infinite.
Of course.
and it has bias in it, right? Like our entire history is a history of bias, basically, as humanity. And so you can't really get out of that sort of very easily.
And it is complex, as you mentioned, because it's not only about avoiding bias today, but also being historically correct and avoiding bias but be accurate at the same time. Another AI principle is to be accountable to people. So always have human control built in. And I think that goes into, is an important point of avoiding potential harmful danger in the future, that human control is always built in.
That's true. It's actually harder than it sounds because humans sometimes want to give up control, so to speak. And I'll give you an example. Is a study done last year in a consulting company, and they gave a sample problem to two sets of consultants. One was not using Gen AI, and the other one was. And they told people to, they're allowed to use Gen AI, but it's actually their work product, right? They are responsible for the outcome, right? Et cetera, et cetera. But still, it sort of happened that if the answers are good enough, people sort of copy and paste, right? And they actually create automation out of something that is supposed to be human driven.
Yeah. Yes.
Right? And so it's actually a very difficult sort of, actually not a technology problem, but actually a human factors problem. How do you create something that does not de facto play out as an automation, even though you have constructed it as an assistant? Right? So that just shows you how complicated sort of that area is. But yes, the idea obviously is that in the end, these systems, in the general sense, are not good enough to do automation. Right? But in actually very narrow things, absolutely can be automation. So this principle is really for general AI and not for specific solutions. I'll give you just a counter example. We have something Google Cloud called Document AI. And basically it says, it's a special solution that says, here's a fax or a PDF I got. It contains a bill. I want to translate that bill into a database record, a structured record, right? Where this is who's billing me. Here's the billing items. Here's a total. Here's a due date or something like that. That is a completely automated solution, right? It's built with AI. It's completely automated, right?
Yes.
No human in the loop, because it's about translating, a PDF or an image into a database record. There's actually no harm there. There's intentionally no human in the loop.
Yes.
Because if you can do that accurately, more accurately than a human did, then, that is fine, right? But it's very different from, let's say, a system that, let's say decides loan applications, right? Or job applications, right? That should not be automated to that degree, because you're making a much bigger consequential decision, and also one where bias is much easier to creep in. If you translate a bill into a structured record,
absolutely,
it's data, right? And sort of bias, perception bias doesn't really come in.
And AI might even be helpful there, because it might turn out to be less biased than a human. But of course, we want that human control. And it's an interesting point that you're making here, that even if we build in this human control, humans by design are made in a way that we minimize effort. So it's not needed. We avoid it, right?
Yes.
So we might be our own challenge. So if we're coming back to Gemini's questions, and I actually think that's a good segue to what you've just said, the last of the high-level questions that Gemini suggested is, you've worked on both the technical and the business aspects of AI. What is the most important thing that you would recommend to businesses now when it comes to AI?
That's a trick question. So I think paradoxically, the way I would phrase it is, it's important to not underestimate it, but also not overestimate it. Underestimate is easy to do because you sort of don't quite know what to do, right? You hear about it, and so you're tempted to say, well, why don't I wait until it sort of shakes out, and maybe it's not ready yet, etc. I think that's a mistake because it is relevant for many business applications today. Right? The technology is good enough to do all kinds of things in a much better way than before. I mentioned document AI, for example. That really is much more capable today than it was even before. Similarly, we have something called contact center AI that's really helps you make a customer service application that's a mix of AI and humans. That is much more capable than in the past. These things are real, right? And it should really not be underestimated. On the other hand, what I sometimes see with customers is that they overestimate what AI can do, and they try to kind of automate their business in a way that really requires intelligence, and these things probably will not work, right? So it's easy to kind of overestimate because the form of the answer is so perfect that you sort of assume that there's a really, nearly perfect brain behind it, and they can actually figure the core problem. That actually doesn't really quite work. So my advice there would be that you want to start with relatively narrow applications of AI and actually, create some successes in places where it's more likely to work, and that gets you the skill, in-house, gets you the confidence, gets your internal users also more used to things like that, and it just creates actually the competence to go and be more ambitious.
So you're saying, get your foot in now, so you can benefit of that extrapolation that you also spoke about in the beginning, what happened at Google, because sometimes you cannot imagine what it means if something grows by 50% every year,
Yes.
but you don't want to miss that boat. So
Absolutely. It's very, getting your foot in the door is, I think, a good way of saying it. You can't understand something that you're not using. And especially if it's changing quickly, by starting to use it, even in small areas, right, in quote unquote simple problems, that really makes it possible for your company to kind of participate in that huge amount of change that's going to happen in the next 5 or 10 years.
And let's maybe take one industry here. By the way, we already touched on most of the questions specific to AI that Gemini suggested. But one point that it suggests we talk about is healthcare and AI in healthcare, where we can see potentially both huge benefits, right? But also some challenges, maybe when it comes particularly to patient data and discrimination. What is your view on that specific industry?
So there I'm actually very optimistic, really for two reasons. First of all, Gen AI, large language model is just one kind of AI, and there's a bunch of others. And like the ability to look at a radiology image and look for cancer in it, or at blood tests and look for signs of disease in there. I think it's very clear that there are strong improvements in healthcare that are possible with the technology that we have today that really fall into none of these risks because they're not particularly ambitious. I'll give you one example that we have done with a number of hospitals. It's about something called sepsis. It's basically a blood infection.
Yes.
You have bacteria in your blood. And it's a very dangerous disease because if you don't treat it quickly, you may die.
Mhm.
On the other hand, it's super treatable, right? If you catch it early, then, antibiotics and you're safe. And the problem is that it gets overlooked. Here's someone admitted for something else in the hospital, and there's many handoffs and many shifts, and you might actually notice too late that this person also has sepsis.
Ah.
And so we did a system in connection with a few hospitals, and it's actually very simple, but it turns out that it discovers sepsis, I forget, like a half a day or 3/4 of a day earlier than average. And all it does is it looks for these symptoms and then alerts a doctor and says, this patient might have sepsis, take a look. And it prevents that from being forgotten accidentally, right? So it actually is not sophisticated at all, but in terms of improving and especially maintaining the standard of care, I expect these kind of things to be really ubiquitous, right? Because in the chaos, so to speak, of a hospital, right, you have all kinds of accidents coming in, et cetera, et cetera. It's very easy to overlook one thing. And that one thing could be what harms the patient. And so having an automated system that looks for these things, it doesn't even need to be correct, right? It needs to just be correct enough and flag it to you and say, hey, please look at this.
Yes.
This could be, right? So if it's wrong half the time, that's okay, as long as it catches all the ones that are suspicious, right? So that's an example of a AI application that I think of which there are dozens and dozens. I'll give you another example. Breast cancer screening, right? Super important. There's this problem of attention blindness in doctors, right? Like you look at x-rays and 99 of 100 pictures that you look at, there's nothing there. Right? It's really hard to still pay attention in 100 pictures and stay focused. It's just super hard as humans. And so if you have a system that doesn't actually try to replicate what the human does, but that tries to say, let me sort out the 2/3 of images where there's absolutely guaranteed nothing in it.
Yeah.
Right? Now I have fewer sort of empties that I look at as a human.
Yes.
And therefore, it's easier for me to do a better job, right?
That's interesting.
Those things are possible too. Again, you didn't replace the doctor, right? You just filtered out the cases where there's nothing to see. And often these solutions actually can be done with very high accuracy, whereas a solution of is there cancer or not, and you answer the whole spectrum of questions might be much harder.
Yes.
You don't need that to make a lot of progress in medical treatment.
Of course. And by that example, for example, we're taking out certain things that we actually don't want to have in a human doctor, like tiredness or exhaustion.
Exactly.
An
Right.
AI
Yes.
is never going to be tired
Yes.
or exhausted. It
Yes.
will look at
Yes.
the thousands
Yes.
picture with the same interest.
Exactly. And so that's what I actually meant for businesses as well. Often there are high impact applications of AI that are not very hard, right? Like it's tempting to think of, let me use AI to diagnose cancer. And of course, that would be awesome, right?
Yeah.
But if you instead say, let me use AI to screen out the non-cancer ones, or at least most of the non-cancer ones, right?
Yes.
That might be much, much simpler. And it still saves you money, right? It improves your quality of care, even though you answered a trivial question versus a fascinating question.
Absolutely. And we want to apply AI to cases like the one you just mentioned, because that's really beneficial. That's use case oriented. The technology is only doing that. And I think with examples like these, we can really understand the potential benefit that AI will have or already has on all of us. I would like to ask you to close one personal question. How do you stay informed about the latest AI developments? There's so much happening at the same time. And how would you recommend others stay informed as well?
That depends on how much time you have. There really is a lot of things going on. I have the benefit of working at Google with lots of smart people who are working on AI. And so there's lots of internal information. And if you can see that, those people are excited about something, then, that's a good filter that it's interesting to look at.
Listen to podcasts like these.
That's right. You can do that. I think really it depends on, again, who you are in terms of, of what level do you want to understand it. But I think we are, at Google Cloud are trying actually pretty hard to regularly produce information that is kind of practically relevant. And then there's lots of podcasts, blogs out there from very good people at sort of different levels of depth. YouTube has a bazillion, AI-related channels, and many of them are actually quite good. And we have pointers in various documentations to our own channels. So I think it's pretty easy to stay informed. Asking Gemini itself actually can work. It's tricky, really, because you want to use it as a pointer to go and look something rather than the final answer. Yes. Because, again, the accuracy challenge is there with any AI system, and it might not fully give you the correct answers.
Yes.
But it will give you pointers. And then if you ask it for pointers, it will give them.
Absolutely. And it will always tell you where the information comes from. So go deeper into that information and read about it. Thank you so much, Urs. Actually, I have asked Gemini for one last favor.
Oh, no.
And that was to write a poem about Urs Hölzle. I've actually then handwritten it to give it a human touch. And here it goes. In Zurich's heart, a tech titan arose, Urs Hölzle with a mind ablaze and bright. From Google's dawn, his influence grows, a guiding light ever shining and right. With code as his brush and vision so keen, he sculpted the cloud, a masterpiece grand. Efficiency's champion forever seen, a legacy etched on digital sand. So let us hail Urs, a titan so rare, whose don't laugh, whose impact on tech will forever contain. In every innovation Google will share, Urs' brilliance and thoughts and vision remain. It's a nice poem. It's very poetic.
I wouldn't necessarily say that.
So this is what Gemini came up with.
Yes. So you can see the AI systems are still flawed.
Well, many things are right in there, I think, as well.
Maybe. No, don't.
Then thank you so much for taking the time for this podcast. We have touched upon many topics today. For example, the developments in AI and generative AI, what your perspective is on the next 5 to 10 years, both benefits, and there might be massive benefits, but also we spoke about some challenges. We touched upon the AI principles that Google is following, and you also explained to us that you highly recommend businesses getting a foot in the door now to start exposing themselves to generative AI so that they can really benefit from the exponential growth that is likely to come in the coming years. Thank you, Urs. And thank you for joining this podcast conversation. I hope you found it interesting and inspiring. It was a glimpse into how Urs envisions and imagines the future. And I hope to see you again for our next episode.